You have launched your EC2 instance and done. Your web server is running. Hold on, is it really a server? Let's explore what's inside of it. Well, you might think that, and conceptually it is a server because you have the web server and your client can reach out to it. It does not necessarily mean that it is running on the physical hardware. And how we can run something online without it running on the physical hardware, and it could be achieved with the concept that called virtualization. So AWS does not rent out their servers to you directly. AWS rents you a virtual machine. While there are still options to rent physical hardware directly, and I'm talking about bare metal hardware, these options are usually very expensive, they are less scalable, and they have much more security overhead. For that reason, AWS uses virtualization. So virtualization concept allows us to run multiple operation systems in one hardware. That way, the AWS customers doesn't have any idea about the structure of their servers, the operation system of their servers. All their servers do, they are just running multiple virtual machines. And when you execute the EC2 task in your AWS console, what you're simply doing, you're just creating a new virtual machine in one of AWS servers. And depending on the resources you have choose when you're creating the instance, this virtual machine will receive all the necessary CPU, RAM, and so on and so forth. However, virtualization comes at a cost. Virtualizing hardware decreases the performance of virtual operation system. Hopefully, there are multiple virtualization types that can leverage performance for the specific use case. While we can't have a generic, unique solution that will be all-purpose virtualization approach, we can find out one approach among different approaches that will let us have optimal performance for our use case. And there are the following virtualization types: Hypervisor-Based Virtualization, S-level virtualization, separate kernel virtualization, and emulation. Before we move forward and talk about each of these types, let's clarify a few more concepts. So virtualization usually have two concepts. It is a host operation system and guest operation system. In most of the virtualization concepts, there is a physical hardware that is running a host operation system. It's similarly to what you have on your computer. Let's say you have Mac or Windows, you have Mac OS or Windows. It's running on your computer. It is the primary operation system. From virtualization point of view, we call it host operation system. And then this host operation system can launch multiple guest operation systems. Those systems would be virtualized by one of the technologies we just mentioned. So hypervisor-based operation system works by the well-known pattern called hypervisor. So it simulates the entire hardware environment, and the guest operation system is not aware that it is using the simulated hardware versus real physical hardware. This approach is often useful for servers consolidation, especially for AWS use case with virtual machines, when they want to have a consolidated operational system that don't have any understanding about the host level. So another type is OS level virtualization. And this concept involves something called kernel. And if we consider how any operational system works, so we have the hardware level, and the hardware level is simply the physical level that operated by bytes 1 and 0. And then we have the operational system level. So kernel level is lets operation system access the hardware. So it transforms the high level operations into low level hardware operations. When it comes to the OS level virtualization, the guest operation systems have a complete access to the kernel. So basically they share the kernel together. They are not using the virtualized simulated hardware like the hypervisor-based optimization uses. Instead, they share the kernel. And it results in their really high performance and lightweight nature because these operation systems are using the real hardware, so they have access to the real hardware. However, this use case might not be appropriate for the server consolidation as far as it does not provide the great control over the resource consumption like the hypervisor-based virtualization does. So this is basically how Docker works, and I will create another video about how the Docker works. So if you're interested what's inside of the Docker container, make sure to subscribe to my channel. So another well-known virtualization way is separate kernel virtualization. So it works similarly to the OS level virtualization, but each of the guest operation system kernel has a dedicated separate kernel. So it means that these systems are completely isolated in terms of security, and they are really well performing in terms of efficiency. However, the biggest limitation that the guest system should be designed to work in the shared kernel optimization. So we can't simply deploy any system we want into shared kernel virtualization concept, because this system, the operation system, should be specifically designed to work about it. And the most common use case for such virtual system is AWS Lambda or GCP Cloud Functions or AWS Fargate. So you know that you can't run any Docker container in AWS Lambda. And the reason for it, because on the lower level, it uses kernel-based optimization that only supports AWS Docker images. So you must run your application within specific AWS Lambda Docker image. One way using Docker with OS level containerization, you are flexible to use any operation system you want, and the guest operation system is not aware about its virtual nature, while in the shared kernel virtualization, the guest operation system actually aware about the kernel limitations. So the separate kernel virtualization also does not necessarily require a host OS. It could be run directly on the hardware, and this approach can run multiple operation systems simultaneously. So in some cases, you might have multiple operation systems installed of your computer, and on the boot level, you can choose whether you want to run Windows or Linux or anything like that. However, you can run one system at a time. But with shared kernel virtualization system, you can run multiple systems simultaneously, and this is the approach AWS takes when it comes to Fargate and AWS Lambda, as I already mentioned. And the last one is an emulation use. And the most common use case for emulation is when you want to run a system with an incompatible processor architecture. So for instance, your hardware is x86 and your operation system is ARM, and you want to run ARM on x86. So the emulation approach completely emulates the computing architecture to combine these two incompatible architectures together. However, it comes in a huge performance cost, so it might not be efficient for all the use cases. So out of all the virtualization types we just described, there are two primarily that used inside of AWS, and these are hypervisor-based virtualization and separate kernel virtualization. So we're running EC2 instances mostly with hypervisor-based virtualization, and actually hypervisor-based virtualization has multiple types. So it could be the bare metal type, which runs directly on the hardware without needing the host operation system. Thus, you can run multiple operation systems simultaneously without multi-boot. But this approach still abstracts out the hardware comparing to the multi-boot, where you have direct access to the hardware. And this is usually the approach most of cloud providers, including AWS, are using to rent out the virtual machines. So they run their virtual machines without the host OS, but just the guest OS on the bare metal using the virtualization concept. While this approach might have performance limitation, AWS managed to set up in a way so it is highly efficient while still providing enough of boundary and security around virtual machines, so the performance bottlenecks by the hypervisor-based virtualization itself are not noticeable for the end customer. Well, the most common approach when it comes to domestic use of the hypervisor-based virtualization is hosted. I can recall it from the time I was working as a software developer in the open sourcing agency, and I was usually doing web development. I had a Mac OS computer, but then this project came on the .NET, and that time .NET was not compatible with any other system than Windows. So I used the VirtualBox machine where I run my Windows, and I was coding and deploying my application here, being on the Mac, but still being able to use Windows flexibly. There is another concept of hypervisor-based virtualization that's called para-virtualization. And this is a really optimized approach to virtualize the hardware, where the host operation system almost using the hardware directly. And why I would say almost, because it does not use hardware directly. It uses the hypervisor API to access the hardware, make it so it's not losing performance on virtualizing and emulating the hardware. However, the downside of this approach comes that the guest operation system should be the specific type that works with hypervisor hardware API, and thus guest operation system is aware that it is a guest operation system. So there is less security and more limitations in terms of the guest operation system that could be used. However, it might be useful for some specific use cases that require performance only, neglecting the security and flexibility. Virtualization is not just about operation systems. Operation systems itself are useless these days as everything is interconnected. Network communication must be virtualized as well to get the most benefits of the virtualization. While discussing these different virtualization approaches, we got acquainted with how virtualization works and how AWS runs their services to millions of customers by just having a few pieces of hardware, so to say. The most important fact about how the customer can access those virtual machines is network. And when you create the AWS account, it has something at a core level that's called virtual private network. And if you want to learn more about virtual private network, check out my another video about how VPC works. And as the name says, this private network is virtual. So what the difference between virtual and physical network involves physical interconnection between machines. So your computer has an Ethernet cable or any kind of other cable that is connected to another computer. And this is how you establish the physical network. In virtual world, when we have virtual operation systems, virtual OS, we want to interconnect between the two systems. And as far as those two systems are virtual, they're running in the host machine, we're using the virtual connection as well. So the virtualization platforms allowing us to, or virtualization mechanism allowing us to interconnect between the two machines. But we all know that simply connecting two machines together is far beyond how large internet global networks works today. The global networks involve different kind of complicated networking hardware like switches, routers, and so on. For that matter, these routers as switches are also virtualized. So they are running like a simple software in some host level machine that allows virtual machines to interconnect to each other. And when you check out the VPC video, you can also find that there are concepts that call NAT gateway and internet gateway. And these are basically the gateways that allow us to assign the public IPs to other services to make them visible to the outside world. In the physical world, we have in our home the Wi-Fi router. And this router actually let us connect to the internet. Our device is connected to this router. We have the private network. But in the virtual world, we have this internet gateway that is basically the software that is running, and our virtual operation system connected to this software, creating virtual networks. That way we can communicate within our virtual machines, as well as communicate with, as well as expose a virtual machine and give it a public IP address, so it will act like a real computer server for the outside world. So this is how AWS works inside. Cheers.